Hey guys, today we are looking at using our properties of radicals to simplify expressions. So there's a note here that says use the same properties as you did with integer exponents. So those same properties, when you multiply, you add the exponents. When you divide, you subtract the exponents. When you use power to a power, you multiply the exponents. But in this case, we're dealing with some roots here. So we have the square root of 6 times the cube root of 6. So if I change these over, which is what I would recommend, the square root of 6 is 6 to the 1/2 times 6 to the 1/3 is our cube root. Well, I'm multiplying. I have the same base, so I need to add the exponents. You can't just add 1/2 and 1/3. We need to get those denominators the same. So the least common multiple there would be 6. So 1/2 would be 3/6, and 1/3 would be 2/6. So then I get 6 to the 5/6 power when I add those exponents, and I could rewrite that then as the 6th root of 6 to the 5th power. Either one of these answers would be acceptable. Since it was already in that root form, you may want to change it back over, but it doesn't matter. Okay. Then for part B, I have 27 to the 1/3 and I have 6 to the 1/4. I'm multiplying those. And all of that is squared. Well, right now, they don't have the same base. So I can't put those two together. But I notice that 27 to the 1/3 is a power that I should know. The cube root of 27 is just 3. And then I have 6 to the 1/4, so that's the 4th root of 6. I'm just going to leave that as 6 to the 1/4 right now. And then square that. So then I need to square each piece to get rid of that squared. So 3 squared is 9. And then 6 to the 1/4, so power to a power means to multiply. So 1/4 times 2 is 2/4, or I have 6 to the 1/2. Well, 6 to the 1/2 is the same as the square root of 6. So that simplifies to 9 square root of 6. And guys, at any time, if you are feeling comfortable with these, pause this and try one of these on your own before I get to it and explain it and see how you do. So this next one, again, don't have the same bases here. So probably going to go ahead and take that negative 1/3 and distribute it inside there. So I have 4 to the 3rd to the negative 1/3. So that's 3 times negative 1/3, that's 4 to the negative 1. And then I have 3 times negative 1/3 again, that's 2 to the negative 1. That negative 1 just tells me to make that 1/4 to the first power and 1/2 to the first power. So that gives me 1/8. All right, then I have 6, and I'm going to go ahead and put a 1 up here. We don't have to write it, but that's helpful. Over 6 to the 3/4. So when I divide, I'm subtracting the exponents. So I have 1, or I could change that 1 to 4/4 if I wanted to. So 4/4 minus 3/4, I have 6 to the 1/4. So, and you could leave that as 6 to the 1/4, or you could rewrite that then as the 4th root of 6. Either one of those would be fine. All right, then I have 18 to the 1/4 over 9 to the 1/4 to the 3rd power. Well, the nice thing here is if they're both to the same exponent, we can pull that exponent off. So then I have 18 over 9, both of those to the 1/4 to the 3rd. So I'm going to do a couple of things at the same time. 18 divided by 9 is 2. And then 1/4 to the 3rd, so 1/4 times 3 is 3/4. So you can leave that as 2 to the 3/4, or that's the 4th root of 2 to the 3rd. And you can do that 2 to the 3rd before you do, make that 3 a little better, before you do the 4th root. So 2 to the 3rd is 8. So now I have the 4th root of 8. So that would be my final answer there. All right, so simplify radicals. Do the same as you would with square roots. So if I have the square root of 8 times the square root of 2, that would be the square root of 16. The square root of 16 in this case would be 4. But you multiply what's underneath the radical. So in that same regard then, if we're looking at part A here, if we're simplifying the cube root of 25, the cube root of 5, I have the cube root of 125. So the cube root of 125 then would be 5. 5 times 5 times 5 would give me 125. All right, and then here, since both of these are the cube root and they're being divided, I can do the cube root of 32 over 4. 32 over 4 is 8. The cube root of 8 is 2. The 4th root of 64, well, let's find a perfect 4th. So 1 to the 4th is 1, 2 to the 4th is 16, 3 to the 4th is 81. That's too big, so 2 to the 4th is 16. 16 goes into 64. So I have the 4th root of 16. 16 times 4 would give me 64. So then I have the 4th root of 16 is 2, and I have the 4th root of 4. But I'm not done there, because 4 also happens to be a perfect square. So I can change that 4 into, I'm going to write this over here. 4 is the same as 2 squared. So when I write that, then if I have the 4th root of 2 squared coming from over here, then I have, if I rewrite this, I have 2 to the 2 over 4. Well, 2 over 4 will reduce. So 2 over 4 is the same as 1/2. And what is the 1/2 power? That's a square root. So now I have 2 square root of 2. Because of all of this simplifying that we just did to get there. That's something we can definitely go over in class if you want to see another example of that. All right, the 4th root of 3 over 5. So we learned that we could break this apart. We have the 4th root of 3 over the 4th root of 5. I could even rewrite that if I want, 3 to the 1/4 over 5 to the 1/4. Well, we talked about with square roots, we would need to multiply the top and the bottom by the same thing to get rid of that denominator. Well, we need to make the denominator a 5 to the first power when we multiply. So how many more fourths do I need to make that a 5 to the first? And so the answer here is that I need 3/4 more. So I'm going to multiply by 3/4 more. Because 5 to the 4th times 5 to the 3/4, when I add those, gives me 5 to the first, or just 5. Then up on the numerator, I have the 4th root of 3 times the 4th root of 5 to the 3rd. So 5 to the 3rd is 125 times 3. So I have the 4th root of 3 times the 4th root of 125, still over 5. I get the 4th root of 375 over 5. You can look for perfect fourths that'll go into that, but I don't believe there's anything there. So we're just going to leave it like that. So then I have the cube root of 2 over 3. We're going to do the same thing on this one. So I'm going to do the cube root of 2. By the way, this would be a great spot to pause the video if you think you know how to do this. Over the cube root of 3. So I'm going to switch this over. I'm going to leave the numerator alone because there's really no reason to switch it. But I'm going to change this to a fraction if it helps you. So 3 to the 1/3. That means I need 2 more thirds to make that a whole. So 3 to the 2/3. So that makes the denominator 3 to the 1st. And then I have cube root of 2 times, I have the cube root of 3 squared. I'm going to go ahead and write as 9. So then I end up with the cube root of 18 over 3. Again, we can go over another example in class if we need to. Alright, then I have the cube root of 12 times the cube root of 4. So, I'm going to multiply those together. So the cube root of 48. So I'm looking for perfect cubes. 1 cubed is 1, 2 cubed is 8. I know that works. 3 cubed is 27. 4 cubed is 81. So that's too big. So, and it doesn't divide by 27. So I think 8 is my largest perfect cube. So I have the cube root of 8 and the cube root of 6. So the cube root of 8 is 2. And then I'm left with the cube root of 6. Alright, last piece we are looking at then is adding and subtracting radicals and roots. So just like when we add with the square roots, we have the square root of 3 square root of 2 plus 5 square root of 2. That sort of works like 3x plus 5x would give us 8x. Same way here, 3 radical 2 plus 5 radical 2 is 8 radical 2. Radical 2 just comes along with it. So the radicand and the index must be the same to be able to add these together. So we have 5 times 4 to the 3/4 minus 3 times 4 to the 3/4. So in this case, 5 minus 3 gives us 2 times 4 to the 3/4. You could do something with that 4 to the 3/4. So 4 to the 3rd is 64 if you wanted to do something with that to the 1/4 power. The 4th root of 64 we can't do anything with, but we do know that 64 is the same as 8 to the 2nd to the 1/4, so that's 8 to the Keep that 2 out front. So we have 2, and then 8 to the 2 over 4, or 8 to the 1/2. So then that's 2 times the square root of 8. The square root of 8 I can break down. Square root of 4, square root of 2. So square root of 4 is 2. So 2 times 2 is 4, radical 2. All right, let's try another one of these. So the cube root of 81 minus the cube root of 3. Well, we can't do anything with that because the 81 and 3 aren't the same. So the cube root of 81, though, I can break up into another perfect square. So I have 3, I have 1 to the 3rd is 1, 2 to the 3rd is 8, 3 to the 3rd is 27. So the cube root of 27 and the cube root of 3 minus the cube root of 3. The cube root of 27 is just 3 cube roots of 3, and this cube root of 3 is really just 1 cube root of 3 if you want to write that. So 3 minus 1 is 2 cube root of 3, and there's nothing we can do to simplify that, so we are stuck with that one as is. All right, the 5th root of 96. So we want to find a 5th root that we can take out. We probably want a 5th root of 3 left over, so doing 96 divided by 3 might be a good hint for you. But we discover then we get the 5th root of 32 and the 5th root of 3 is 96, and I'm going to bring my minus 4 times the 5th root of 3 along with it. So the 5th root of 32 is 2 5th root of 3 minus 4 5th root of 3. So 2 minus 4 is negative 2, the 5th root of 3. Notice I'm being careful to write that 5th root away from that negative 2 so it doesn't look like negative 2 to the 5th power. So just be careful with how you're writing those things. All right, guys, that is all I have for today's lesson. I know there's a lot of stuff in there with simplifying. We'll definitely be practicing a lot of these. So if you have questions, come in and see me. Otherwise, I'll see you in class.